Good day, students. Let us focus on atoms and molecules. Have you ever wondered what everything around us is made of? Long ago, around 500 BC, the Indian philosopher Maharishi Kand proposed a fascinating idea, divisibility of matter. He said that if we keep dividing matter, we finally reach the smallest particle which cannot be divided further. He called it Parmanu and matter is called as Padarth. Another thinker, Pakuda Katayama, explained that these tiny particles combine in different ways to form the variety of matter we see. At the same time in Greece, philosophers like Democritus and Leucippus had similar ideas. Democritus named these indivisible particles atoms, meaning cannot be divided. But remember, these were only ideas, not experiments. It was only in the 18th century that science progressed. Scientists began to understand elements and compounds. One major breakthrough came from Antony Lavoisier, who laid the foundation of modern chemistry by giving important laws of chemical combination. Laws of chemical combination. The journey of atomic theory began with the query: when a chemical reaction happens, does the mass change? Does the mass change? Or do elements always combine in the same way? These questions were answered by scientists like Antony Lavoisier and Joseph Louis Proust by way of two fundamental laws, the law of conservation of mass and the law of constant proportions. The law of conservation of mass and the law of constant proportions. Let's perform a simple experiment. Take two solutions. The solution set can be copper sulfate and sodium carbonate, barium chloride and sodium sulfate, lead nitrate and sodium chloride. Let us consider copper sulfate and sodium carbonate. Prepare a 5% solution of each in 10 ml of water. Keep copper sulfate in a flask, sodium carbonate in an ignition tube. Place the tube inside the flask. Close it with the cork. Close it with the cork. Make sure they do not mix initially. Weigh the flask with contents. Now tilt the flask. The solution mixes. Reaction happens. Weigh again. Will the mass change? Will the mass change? No, the mass remains the same. This is called the law of conservation of mass, as the mass remains the same. So, the law of conservation of mass states that the mass can neither be created nor destroyed in a chemical reaction. In the experiment, we made sure that we closed the flask. Why did we close the flask? To prevent anything from escaping. So, total mass remains constant. Here comes the interesting part. Scientists observed something more. In any compound, elements are always present in a fixed ratio by mass. That is law of constant proportions. Take water, be it from natural source or synthetic laboratory source. The proportion of hydrogen and oxygen is 1 is to 8 in water. That is 9 grams of water decomposes into 1 gram of hydrogen and 8 gram of oxygen. Now take ammonia. The nitrogen and hydrogen proportion is 14 is to 3. That is 17 gram of ammonia decomposes into 14 part nitrogen and 3 part hydrogen. This is called the law of constant proportions. Joseph Louis Proust stated, elements are always present in definite proportions by mass. Elements are always present in definite proportions by mass. Now, the question was, why do these laws work? Why do these laws work? The answer was given by John Dalton. John Dalton was born in 1766. He was a teacher at 12 years of age, a school principal by 19 years of age. He was placed at University of Manchester around 1793, and in 1808 he presented his atomic theory. His postulates are: matter is made of atoms, atoms take part in reactions, atoms cannot be created or destroyed, atoms of same element are identical, different elements have different atoms, atoms combine in simple ratios, composition of compounds is fixed. His core idea is all matters is made of tiny particles called atoms. All matter is made of tiny particles called atoms. Today we know atoms can be divided further, but Dalton's theory was the foundation. So remember, mass is always conserved, compounds have fixed composition, atoms explain these laws. If you found this video helpful, subscribe. Let us meet in the next video. Thank you.